Hello viewers, in today's video, we want to use the oxidation number of element or radical to determine the formula of a compound, whether that compound is correct, whether it is not correct. For instance, you have a compound like this, Na2SO4 and Na. Is this one correct or is this one correct? This video is we are going to look at we are going to tackle some of the problem that arises from this kind of where you can use and plug our oxidation number. Then for the one of radicals, I will also write the radicals compound, then give you their oxidation number. Now watch out. We have we'll first of all look at our periodic table this way. This is 1 2 3 4 5 6 7 and 0. So we have this 0. We have this is a simple form of constructing a periodic table. We have something like this. This hydrogen, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, this helium, this neon, this is sodium, magnesium, aluminium, silicon, phosphorus. We have sulfur, we have chlorine, we have argon, we have potassium, and we have calcium. So just know that why we need this is because of the oxidation number that we want to determine. Just know that group 1 here, this one here, all the members have oxidation number of 1 plus 1. We call it 1 plus, or you call it plus. We have 2 plus, this one 3 plus, this one is 4 plus, and this one from here you have what? 3 minus, 2 minus, that's minus 1, and this one is the oxidation number of 0. Now for the radical, we want to look at, if you see something like this, PO4 has oxidation number of 3 minus. If you see something like this, CO3 has oxidation number of what? 2 minus. If you see something like this, NO3 has oxidation number of minus. If you see something like this, SO4 has oxidation number of 2 minus. If you see something like this, Na4 has oxidation number what? Plus. If you see something like this, OH has oxidation number what? Minus. So these are all, we consider them as what? Radical. We are going to use it and write the name of our compound. And the next thing that you need to know is that when a compound is written like this, for instance, I want to write the formula of calcium chloride. What do I say? Calcium chloride, CaCl. This is what? Calcium chloride. You begin to ask yourself, is this formula correct? Is this formula of calcium chloride correct? Now, when looking at it, what you have to do is that write the oxidation number. Write the oxidation. Calcium here belongs to group 2. Look at calcium here. So it has oxidation number what? 2. You write here C plus. We have 2 plus. Chlorine here have what? Cl and 1. Chlorine belongs to group 7. So it has oxidation number minus 1. So now here you are not going to consider the sign. Are you following? You are not going to consider the sign, whether it is plus, whether it is minus. Okay, so you leave the minus side. You just know that if it is minus like this, it has 1. If it is only plus, you have what? 1. So now this one that is minus here, we consider it to be what? To be 1. This one that is 2 plus, we consider it to be 1, to be 2. Are you following? Now we are going to cross. These 2 here will go to chlorine now, while 1 here will come to what? Come to calcium. So we now have Ca. You bring the 1 down, then you now write Cl. You bring the word 2 down. Do you get that? You should know that Ca1 is the same thing as what? Ca. Do you get that? 1 times any number is what? Is that same number. So we have what? Cl2. So the correct formula of this compound is CaCl2. That is calcium chloride. We'll move again. What if you are given a compound like Na2, Na2NO3 and NO3. Which one is the correct formula? Now split the compound into two. We have N here, and we have what? NO3. Now I told you that NO3 exists as a radical and has oxidation number. Look at it here. Has oxidation number what? 1 minus 1. I just write it 1 because we say that the sign does not count. Na has oxidation number 1. It belongs to group 1 of the periodic, so it has oxidation number 1. Do you get that? Now we have to exchange the radical. Since 1 and 1 are the same, so you cancel the 1, cancel this one. So this one, if there are 2 here, if it is 2 here, 2 here, by the time the powers, the oxidation powers are the same, you cancel them. Okay, so 1 will cancel here, 1 will cancel. So now I have NO3. So this one is the correct one. This one is wrong. Are you following? Now, what you have a compound like this? H2PO4, H3PO4, HPO4. Which one is the correct formula among these three? So now we are going to split them. We split to have what? Hydrogen here. We have what? PO4. PO4 here, that is tetraoxophosphate, exists as what? As a radical. Now this tetraoxophosphate has oxidation of what? -3. So I told you that the sign doesn't mean, so we have to put what? Put 3 here. Hydrogen here has oxidation number, belongs to group 1, so has oxidation number 1, so put 1 here. You understand? They are going to exchange. So this one will come to this side, this 3 will come to this side. So the formula will now be what? H3PO4. 1 times this one will still give you this one. So the correct formula is what? Is this one. I hope you are following. If you have any problem with this, please drop it on the comment section. Are you following? Now you can as well share this video to as many as possible, more especially for those who are preparing for JAM. This is Ojemai YouTube channel. You can as well follow us on Facebook on Ojemai Online Chemistry. Let's continue so that you take this one as your signing. Now in a situation where you have something like this, where you have something like CaOH, you now begin to ask yourself, this is calcium hydroxide. Now that is quick line. Now you begin to ask yourself, is this compound correct? Let us see whether it is correct. This OH is a radical, is this as a single unit, so we have Ca and we write what? OH. Do you get that? Now what you do is that Ca here has oxidation number what? 2, so we write our 2. OH here has oxidation number what? Look at it here, -1, so we have what? 1. So now they will not take the position of another one. Ca will not take the position of what? OH. So Ca have what? 2 here. So let us say we'll take the position of this one, while this one here will take the position of this one. So here now will now be what? We'll put in a bracket, right? 2, because if you sodium chloride. Sodium chloride is NaCl. Ask yourself, is this thing correct or not? Now, if you want to look at how they are bonded, it is ionic bonding or electrovalent bonding. Sodium here in its atom shell has oxidation, has a lone pair of electrons, while chlorine here has what? 7 pairs of electrons in the atom shell. Instead of you to begin to draw this thing now, 1, 2, 3, 4, 5, 6, 7, so that this one will not transfer and give to this one, so that they can form a compound like this. This one is too long for you to, that one is too long. That one, we don't apply those kind of thing in chemistry unless you are just asking a theoretical way. But if you are asking an objective way, like in the case of JAM, you use this formula. So you split them into 2, Na and what? Cl. Na here has what? 1. Cl here has what? 1. Cl, remember oxidation number of chlorine in a binary stage what? -1. But I told you that we don't consider the charges, we only consider the number. So 1 and what? 1. So 1 will cancel here, 1 will cancel. So we have NaCl. Are you following? If you find this video interesting, please do share to as many as possible Share it to the people that are preparing for jam, and also those who are preparing for any external exams. Any question, drop it on the comment section. You can as well follow us on Facebook like I earlier said, or you subscribe to my YouTube channel. Thank you.